NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve logarithmic equations by converting them to exponential form. We'll use the key rule, log base a of f of x equals b if and only if f of x equals a to the power b. We'll apply it to several quick examples and check domains. Before using the rule, remember the conditions. The base must be positive and not equal to 1, and the argument of the logarithm f of x must be strictly positive. X raised to log base x of the quantity x plus 3 squared equals 16. Step 1. Domain restrictions for the logarithm. The base x must be greater than 0 and not equal to 1. Step 2. Apply the identity b to the log base b of a equals a. Therefore, the left side simplifies to the quantity x plus 3 squared. Step 3. Take square roots. X plus 3 equals plus or minus 4. Hence x equals -7 and x equals 1. Step 4. Check the domain. -7 violates x greater than 0, and x equals 1 violates base not equal to 1. Therefore, the solution set is empty. Now, the second equation. Second equation. 7 raised to log of x equals 98 minus x raised to log of 7. Step 5. Use the property a to the log of b equals b to the log of a, assuming the same log base. Replace x to the log of 7 with 7 to the log of x. Step 6. Add 7 to the log of x to both sides. That gives 2 times 7 to the log of x equals 98. Therefore, 7 to the log of x equals 49. Step 7. Recognize 49 as 7 squared. With equal bases, exponents are equal, so log of x equals 2. Step 8. Convert the common logarithm to exponential form. X equals 10 squared, which is 100. The domain requires x positive. 100 works, so the solution set is braces 100. Summary. Example A. Solve the equation exactly as shown in the source. 16 to the log of x squared equals 8. This is 2 to the 4 times log of x squared equals 2 to the 3. Therefore, 4 times log of x squared equals 3. So log of x squared equals 3/4. Converting to exponential form with base 10 gives x squared equals 10 to the 3/4. Write the fractional power as a radical x squared equals the 4th root of 10 cubed. Taking square roots yields x equals plus or minus the square root of the 4th root of 10 cubed. Combine the nested radicals x equals plus or minus the 8th root of 10 cubed. Since 10 cubed is 1000, we can write x equals plus or minus the 8th root of 1000. The solution set is D equals the set containing plus or minus the 8th root of 1000. Quick recap of problem A. Same base comparison. Then isolate the logarithm, convert to exponential form, and carefully manage radicals to reach the final set. Example B. Solve exactly in the stated order. 3 times x to the log base 5 of 2 plus 2 to the log base 5 of x equals 64. Domain, reminder x greater than 0. Recall the identity x to the log base a of y equals y to the log base of x. So x to the log base 5 of 2 equals 2 to the log base 5 of x. Substitute to get 3 times 2 to the log base 5 of x plus 2 to the log base 5 of x equals 64. Combine like terms to obtain 4 times 2 to the log base 5 of x equals 64. Hence 2 to the log base 5 of x equals 16. Rewrite 16 as 2 to the 4th. Therefore, log base 5 of x equals 4. Converting to exponential form gives x equals 5 to the 4th. So x equals 625. And the solution set is D equals open brace 625 close brace. Solve the equation. Log of square root of x equals square root of log x. We will mirror the exact step order of the provided algorithm. Step 1. Determine the domain. We need x greater than 0, and we also need the expression inside the square root log x to be greater than or equal to 0. Thus, x is at least 1. Step 2. Rewrite square root as a 1/2 power. So log of x to the 1/2 equals square root of log x. Step 3. Apply the power rule of logarithms. The exponent comes down in front. 1/2 times log x equals square root of log x. Step 4. Square both sides to remove the square root. 1/4 times log squared x equals log x. Step 5. Bring all terms to one side. 1/4 log squared x minus log x equals 0. Step 6. Factor out log x. So we get log x multiplied by 1/4 log x minus 1 equals 0. Step 7. Use the zero product property to get two cases. First, log x equals 0, which implies x equals 10 to the 0 or 1. Second, 1/4 log x minus 1 equals 0. So log x equals 4, which implies x equals 10 to the 4th, or 10,000. Therefore, the solution set is curly brace 1, 10,000. Example 2. Solve the equation. Open parenthesis log x close parenthesis squared plus log x plus 1 equals 7 divided by log of x over 10. Again, we will follow the exact sequence from the algorithm. Step 1. Use the quotient rule for logarithms. Log of x over 10 equals log x minus log 10. Step 2. Evaluate log 10, which equals 1 in base 10. So the denominator becomes log x minus 1. Step 3. Multiply both sides by log x minus 1. The left becomes the product of a quadratic in log x and log x minus 1, and the right becomes 7. Step 4. Expand the product. We get log x cubed plus log x squared plus log x minus log x squared minus log x minus 1 equals 7. Step 5. Combine like terms. The middle terms cancel, leaving log x cubed minus 1 equals 7. Step 6. Add 1 to both sides. We get log x cubed equals 8. Step 7. Observe that 8 equals 2 cubed, so log x equals 2. Step 8. Convert from logarithmic form to exponential form. Therefore, x equals 10 squared, which is 100. Finally, check the domain x must be positive and log of x over 10 must not be 0, which means log x is not 1. Our solution x equals 100 satisfies this, so the solution set is curly brace 100. Great work, 100. Great work. In both problems, we converted roots to exponents, applied log rules, turned the equations into algebra in terms of log x, and solved carefully within the domain. Problem 1. Step 1. Write the original equation. Step 2. Apply the power rule of logarithms. Step 3. Use the domain condition from log of negative x to replace absolute x by negative x. Step 4. Combine like terms. Step 5. Isolate the logarithm. Step 6. Convert to exponential form, base 10. Step 7. Solve for x. Step 8. State the solution set. Problem 2. Step 1. Write the original equation. Step 2. Move the coefficient 2 into the logarithm using the power rule in reverse. Step 3. Use the identity a to the log base a of b equals b. Step 4. Take square roots to get an absolute value. Step 5. Split the absolute value into plus or minus. Step 6. Solve both linear equations. Step 7. Apply the domain of the logarithm to keep only valid solutions. We start with the equation 5 to the log x plus x to the log 5 equals 50. Reminder of the key identity, x raised to log base of y equals y raised to log base of x. We apply it to rewrite x to the log 5 as 5 to the log x. This gives 5 to the log x plus 5 to the log x equals 50. Combine like terms. 2 times 5 to the log x equals 50. Divide by 2. 5 to the log x equals 25. Write 25 as 5 squared. Then we can equate exponents. With equal positive bases, exponents are equal. So log x equals 2. Convert from logarithmic to exponential form, x equals 10 squared. Therefore, x equals 100. The solution set is the set containing 100. Example 2. We now solve 5 to the log x minus 3 to the log x minus 1 equals log x minus 1 equals 3 to the log x plus 1 minus 5 to the log x minus 1. Move terms to group the same bases together. Add 5 to the log x minus 1 to both sides, and add 3 to the log x minus 1 to both sides. We obtain 5 to the log x plus 5 to the log x minus 1 equals 3 to the log x plus 1 plus 3 to the log x minus 1. Factor out the common powers using exponent rules. On the left, factor 5 to the log x, leaving 1 plus 1/5. On the right, factor 3 to the log x, leaving 3 plus 1/3. Evaluate the parentheses. 1 plus 1/5 equals 6/5. 3 plus 1/3 equals 10/3. Divide both sides by 3 to the log x and by 6/5. This yields the ratio 5 to the log x over 3 to the log x equals 25/9. Use the quotient rule. A to the m over b to the m equals parentheses over b to the m. So left side becomes 5/3 to the log x, which equals 5/3 squared. Equal positive bases imply equal exponents, giving log x equals 2. Convert to exponential form. X equals 10 squared, which is 100. Thus, the solution set once again is the set containing 100. We show the problem. Then we enforce the domain. Step 1. Take log base 2 of both sides to bring exponents down using log rules. Step 2. Apply the product rule and power rule of logarithms. Step 3. Rewrite 1/4 as 2 to the power negative 2 and simplify log base 2 of 2 to 1. Step 4. Evaluate log base 2 of 2 to the negative 2, which equals negative 2. Step 5. Move the quarter term to the left and combine. This yields the square of log base 2 of x equals 8. Step 6. Take the square root of both sides, which introduces an absolute value. Step 7. Split into two cases and convert from logarithmic to exponential form. Example. We will solve the logarithmic equation exactly following the given step order. The equation is the square root of x raised to the power log of the square root of x equals 10. Step 1. Square both sides to remove the square root base. That gives x raised to the log of the square root of x equals 100. Step 2. Take the common logarithm of both sides. Step 3. Use the power rule of logarithms. Log of a to the b equals b times log a. So, log of the square root of x times log x equals 2. Step 4. Rewrite the square root of x as x to the 1/2. Step 5. Apply the power rule again on log of x to the 1/2. That brings 1/2 out front. Step 6. Combine the two identical factors. 1/2 times the square of log x equals 2. Step 7. Multiply both sides by 2. The square of log x equals 4. Step 8. Take square roots. Log x equals plus or minus 2. Step 9. Solve each case. If log x equals 2, then x equals 10 squared, which is 100. If log x equals negative 2, then x equals 10 to the negative 2, which is 1/100. Step 10. Apply the given domain. Check x must lie strictly between 0 and 1. The value 100 is outside this interval, while 1/100 is inside. Therefore, the solution set contains only one value, 1/100. Recap. We squared both sides, took logarithms, used the power rule twice, formed 1/2 times log x squared equals 2, solved for log x equals plus or minus 2, and finally used the domain x in open 0, one to keep only 1/100. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.